The Great Red Spot: Exploring Jupiter and Its Mystery. Hey guys, welcome to Space Explorer channel. Jupiter has been a mystery to astronomers for centuries. With its vast array of moons and intense storms, it has captivated and intrigued scientists for generations. One of the most intriguing features of Jupiter is the Great Red Spot, an immense and powerful storm that has been raging for centuries. In this video, we'll explore the Great Red Spot, discuss its history, and uncover some of the secrets of Jupiter that the storm may hold. So if you're looking to learn more about the mysteries of Jupiter, read on. Before moving forward, if you are new to our channel, don't forget to like and subscribe to our channel for future interesting videos. History of the Great Red Spot. The history of the Great Red Spot dates back centuries, and its origins remain a topic of debate among astronomers. The earliest recorded observations of the storm can be traced back to the 17th century, when astronomer Robert Hooke observed a large spot on Jupiter in 1664. However, it wasn't until the 19th century that the Great Red Spot truly captured the attention of scientists. In 1831, the astronomer and mathematician William Dawes made detailed observations of the Great Red Spot, providing valuable insights into its behavior and structure. Throughout the 19th and 20th centuries, astronomers continued to document and study the storm, refining their understanding of its size, shape, and characteristics. One of the most significant breakthroughs in our understanding of the Great Red Spot came in the 1970s with the arrival of the Voyager missions. The Voyager spacecraft provided unprecedented close-up images and data of Jupiter and its storm. These images revealed the intricate cloud patterns within the Great Red Spot and helped scientists estimate its wind speeds, which can reach over 400 miles per hour. In recent years, advances in technology have allowed for even more detailed observations of the Great Red Spot. Space telescopes like the Hubble Space Telescope have captured stunning images of the storm, providing further insights into its composition and behavior. While we have made great strides in understanding the Great Red Spot, its exact origins remain elusive. There are several theories that attempt to explain how this massive storm formed. Some scientists believe that it may have originated as a smaller storm that gained strength over time, while others propose that it formed from a collision between smaller storms. Another mystery surrounding the Great Red Spot is its changing size. In the 1800s, the storm was estimated to be about 25,000 miles in diameter, making it large enough to engulf the entire Earth. However, in recent decades, the storm has been shrinking. Current observations suggest that it is now approximately 10,000 miles in diameter. Despite these mysteries, the Great Red Spot continues to intrigue scientists and capture the public's imagination. Its immense size and long lifespan make it a unique and fascinating feature of our solar system. As we continue to explore and study Jupiter, we hope to uncover more of the secrets held within the Great Red Spot and gain a deeper understanding of this remarkable storm. The appearance and location of the Great Red Spot. The Great Red Spot is an iconic feature of Jupiter, known for its distinctive appearance and prominent location on the planet's surface. This massive storm is easily recognizable with its swirling red and orange hues, contrasting against the surrounding cloud bands. Located in Jupiter's southern hemisphere, the Great Red Spot is typically found in a region known as the South Equatorial Belt. This belt is characterized by alternating light and dark bands of clouds that encircle the planet. The storm itself is situated within one of these dark bands, creating a stark contrast with the surrounding atmosphere. The appearance of the Great Red Spot has changed over the centuries as astronomers have observed it. Early descriptions described it as a permanent spot, suggesting a more compact and stationary feature. However, modern observations reveal a more complex and dynamic storm, with swirling cloud patterns and changing shapes. The colors of the Great Red Spot are thought to be a result of chemical compounds within Jupiter's atmosphere. One theory suggests that the red color comes from compounds called chromophores, which are formed by the interaction of sunlight and chemicals like phosphorus or sulfur. These compounds give the storm its distinct reddish hue, while the varying shades of orange and brown are believed to be caused by different concentrations of these chemicals. The size of the Great Red Spot has also been a subject of fascination for scientists. As mentioned earlier, it has been shrinking in recent decades. While it was once estimated to be about 25,000 miles in diameter, it is now approximately 10,000 miles in diameter. The reasons behind this shrinkage are still not fully understood, but it may be related to changes in the storm's circulation patterns or the surrounding atmospheric conditions. The location and appearance of the Great Red Spot make it a prime target for observation and study. Scientists use telescopes and spacecraft to capture images and data, helping to unravel the mysteries of this enigmatic storm. By analyzing the cloud patterns, winds, and composition of the Great Red Spot, researchers hope to gain a deeper understanding of its behavior and what drives its longevity. In the next section's video, we will explore some of the current theories on the origin of the Great Red Spot, as well as its evolution over time. By delving into these topics, we can further appreciate the complexity and significance of this iconic storm on Jupiter. So let's continue our journey of unraveling the secrets of the Great Red Spot. Current theories on the origin of the Great Red Spot. The origin of the Great Red Spot on Jupiter is still a topic of debate among scientists. While there is no consensus on the exact cause of this massive storm, several theories have been proposed to explain its formation. One theory suggests that the Great Red Spot may have originated as a smaller storm that gained strength over time. According to this theory, the storm may have started as a small disturbance in Jupiter's atmosphere, possibly caused by a collision with another storm or a change in atmospheric conditions. Over time, this disturbance grew in size and intensity, eventually becoming the massive storm we see today. Another theory proposes that the Great Red Spot formed from a collision between smaller storms. Jupiter's atmosphere is known for its turbulent and chaotic nature, with numerous storms and cloud systems constantly interacting and evolving. It is possible that the collision of two or more of these storms gave rise to the Great Red Spot. This theory suggests that the energy released during the collision fueled the growth and longevity of the storm. Some scientists believe that the Great Red Spot may be a result of the planet's unique atmospheric dynamics. Jupiter is a gas giant with a complex and dynamic atmosphere, characterized by strong winds and intense storms. These atmospheric conditions may create the ideal environment for the formation and persistence of a storm like the Great Red Spot. Additionally, it is worth considering the role of Jupiter's magnetic field in the formation of the Great Red Spot. Jupiter's magnetic field is extremely powerful and can influence the planet's atmospheric dynamics. Some scientists believe that the interaction between the magnetic field and the planet's atmosphere may play a role in the formation and maintenance of the Great Red Spot. While these theories provide possible explanations for the origin of the Great Red Spot, more research and data are needed to determine the true cause of this enigmatic storm. Future missions and observations, such as those conducted by NASA's Juno spacecraft, will continue to provide valuable insights into the formation and evolution of the Great Red Spot. Understanding the origin of the Great Red Spot is not only crucial for unraveling the mysteries of Jupiter, but it also has implications for our understanding of planetary weather systems in general. By studying this massive storm, scientists can gain valuable insights into the atmospheric processes and dynamics of gas giants, which can be applied to other planets within our solar system and beyond. In the next section of this video, we will explore the evolution of the Great Red Spot over time, shedding light on the changes and transformations that this iconic storm has undergone throughout its long history. So stay tuned for more fascinating insights into the mysteries of Jupiter's Great Red Spot. The evolution of the Great Red Spot over time. The Great Red Spot on Jupiter has fascinated astronomers for centuries, not only because of its immense size and powerful storms, but also because of its evolution over time. Throughout history, scientists have observed significant changes in the appearance and behavior of this iconic storm. Early observations of the Great Red Spot described it as a permanent spot, suggesting that it was a more compact and stationary feature. However, as technology and observation methods advanced, astronomers began to uncover a more dynamic and ever-changing storm. One notable change in the Great Red Spot is its size. In the 1800s, the storm was estimated to be about 25,000 miles in diameter, making it large enough to engulf the entire Earth. But in recent decades, the storm has been shrinking. Current observations suggest that it is now approximately 10,000 miles in diameter. The reasons behind this decrease in size are not yet fully understood, but scientists speculate that changes in the storm's circulation patterns or the surrounding atmospheric conditions may play a role. Another significant evolution of the Great Red Spot is its changing color. Early observations described the storm as primarily red, hence its name. However, in recent years, the storm's color has shifted towards a more orange hue. Scientists believe that this change in color may be due to variations in the concentrations of chemical compounds within Jupiter's atmosphere. In addition to changes in size and color, the Great Red Spot has also exhibited alterations in its shape and structure. Over time, astronomers have observed the storm's cloud patterns evolving and swirling in complex and intricate ways. These changes may be influenced by the storm's interactions with the surrounding atmospheric conditions, as well as the turbulent nature of Jupiter's atmosphere. Understanding the evolution of the Great Red Spot is essential for unraveling the mysteries of this enigmatic storm and gaining insights into the atmospheric dynamics of gas giants. By studying its changes over time, scientists can uncover valuable information about the processes and mechanisms that drive the storm's behavior and longevity. In the next section of this video, we will explore the mystery surrounding the Great Red Spot's disappearance and discuss possible explanations for its eventual fate. Stay tuned for more fascinating insights into the mysteries of Jupiter's Great Red Spot and its evolution over time. The mystery surrounding the Great Red Spot's disappearance. The Great Red Spot on Jupiter has long been a prominent and iconic feature of the planet's atmosphere. For centuries, astronomers have observed and studied this massive storm, documenting its size, shape, and behavior. However, in recent years, there has been growing concern over the gradual disappearance of the Great Red Spot. Scientists have noticed a significant decrease in the storm's size over the past few decades. From once being estimated at about 25,000 miles in diameter, the Great Red Spot has now shrunk to approximately 10,000 miles. This shrinking has led to speculation about the eventual disappearance of the storm. The exact reasons behind the Great Red Spot's disappearance remain a mystery. There are several possible explanations that scientists have proposed, but none have been definitively proven. One theory suggests that changes in the storm's circulation patterns may be responsible. Jupiter's atmosphere is known for its complex and dynamic nature, with strong winds and intricate cloud patterns. It is possible that shifts in these patterns have disrupted the stability of the Great Red Spot, leading to its gradual demise. Another possibility is that the surrounding atmospheric conditions have changed, making it less favorable for the formation and persistence of the storm. Jupiter's atmosphere is composed primarily of hydrogen and helium, with smaller amounts of other compounds. Variations in the concentrations of these compounds, such as ammonia and methane, could potentially affect the formation and behavior of the Great Red Spot. Changes in temperature and pressure could also play a role in the storm's disappearance. It is also worth considering the role of Jupiter's magnetic field in the disappearance of the Great Red Spot. Jupiter has an extremely powerful magnetic field, which can influence the planet's atmospheric dynamics. The interaction between the magnetic field and the storm could have played a role in its eventual demise. While the exact fate of the Great Red Spot remains uncertain, scientists are closely monitoring its behavior and changes. Continued observations and data collection will be crucial in understanding the storm's disappearance and unraveling the mysteries of Jupiter's atmosphere. Future missions, such as NASA's Juno spacecraft, will provide valuable insights into the evolving nature of the Great Red Spot. Future exploration and research of Jupiter's Great Red Spot. As we continue to uncover the mysteries of Jupiter's Great Red Spot, future exploration and research will play a crucial role in deepening our understanding of this enigmatic storm. Scientists are eagerly planning and preparing for missions that will provide further insights into the behavior, composition, and evolution of the Great Red Spot. One of the most significant upcoming missions is NASA's Juno spacecraft, which is currently orbiting Jupiter. Juno's primary objective is to study Jupiter's atmosphere, including the Great Red Spot, in unprecedented detail. Equipped with a suite of scientific instruments, Juno is providing valuable data on the storm's composition, winds, and dynamics. This data will help scientists refine their models and theories on the origin and evolution of the Great Red Spot. In addition to Juno, other future missions are being considered to further explore the mysteries of Jupiter. These missions include orbiters and probes that would focus specifically on the Great Red Spot, providing even more detailed observations and measurements. These missions would allow scientists to investigate the storm's inner structure, atmospheric processes, and potential interactions with Jupiter's magnetic field. Furthermore, advances in technology and observation techniques will continue to enhance our understanding of the Great Red Spot. New ground-based telescopes, such as the Giant Magellan Telescope and the European Extremely Large Telescope, will have the capability to capture high-resolution images and spectroscopic data of Jupiter and its storm. These observations will enable scientists to study the storm's chemical composition, cloud formations, and changes over time with even greater precision. Additionally, ongoing research efforts are focused on analyzing the vast amount of data collected by past missions, such as the Voyager and Galileo spacecraft. By revisiting and reanalyzing this data, scientists hope to uncover new insights and connections that will contribute to our understanding of the Great Red Spot's behavior and evolution. Ultimately, the future exploration and research of Jupiter's Great Red Spot hold the potential for groundbreaking discoveries and a deeper understanding of the complex dynamics of gas giant atmospheres. By combining data from current missions, future missions, and advanced observation techniques, scientists are poised to unlock the secrets of this iconic storm. As we eagerly await the findings from these future missions and research efforts, one thing is certain: the Great Red Spot will continue to captivate and inspire scientists and the public alike. Its longevity, immense size, and changing behavior make it a fascinating and unique feature in our solar system. The ongoing exploration and study of the Great Red Spot will undoubtedly lead to new discoveries, pushing the boundaries of our knowledge and expanding our understanding of the wonders of Jupiter and the mysteries of our universe. The Great Red Spot is a long-lived spinning vortex. Even Victorian-era astronomers provided carefully drawn pictures and descriptions of the large red blemish on Jupiter's clouds. But it might have persisted for even longer than that. Observations by 17th-century astronomers Robert Hooke and Giovanni Cassini suggest a similar feature, so it might have been around for almost 4 centuries or longer. But what has kept it going for so many human lifetimes, and why is there no other vortex that comes close to matching it? We've known that the spot is shrinking for many years, as the size measured by Earth-based and space-based observatories, including Hubble, has been tracked over time. Voyager measured a width of 15,534 miles in 1979, but that's now decreased to as little as 9,942 miles, only just wider than the 7,891 miles diameter of the Earth. But the shrinking has been neither continuous nor uniform. The spot went through a period of rapid shrinkage between 2012 and 2014, but has now appeared to stabilize at the new smaller size. Who knows whether we'll ever witness the death of the spot, or whether it will remain a permanent fixture of Jupiter's churning atmosphere. The Great Red Spot rolls like a ball bearing between two of Jupiter's prominent bands, whose atmospheric jet streams act as conveyor belts for smaller storm clusters, eddies, and vortices. However, if these storms are unlucky enough to meet the Great Red Spot, they are engulfed by it. Maybe these smaller vortices provide the extra energy and angular momentum needed, rotational energy locked up in orbital motion and spin, to sustain the swirling maelstrom. But we can't know for sure. The mix of gases and clouds found within the spot also suggests there is a powerful upsurge, known as an upwelling, at the center, which could be transporting heat upwards to sustain the vortex. The new high-resolution images show the core of the storm as a deep red color, with exquisite detail that will teach us more about the dynamics within the heart of the spot. If you were somehow able to fly a balloon at the edge of the swirling storm, you'd be blown around the vortex in about 3.5 days. Yet the Great Red Spot is not quite the same as a hurricane. There's no ocean beneath to sustain the energy of it, and nobody truly knows how far down it extends into the deep atmosphere. Is it just a feature in the upper clouds? Or could it be deep-rooted, dredging chemicals from Jupiter's interior, which might explain why it has been stable for so long? The new images, coupled with Juno's microwave and gravity observations, could reveal, for the first time, how far down that spot really goes. Despite decades of planetary exploration, we still don't know how the gases in Jupiter's cloud tops react to create the red coloration we see in the spot. For that matter, it's not always red. Sometimes it'll fade to orange, or take on hues of salmon pink or rusty brown. These colors may be related to sunlight breaking down the chemical bonds of materials dredged up by the upwelling in the storm. These chemically altered species might contain compounds of sulfur, phosphorus, and hydrocarbons, which could lead to the red colors. Juno's suite of instruments, coupled with these spectacular new images, might shed light on this mystery. At the cloud tops, the Great Red Spot is cold because air is rising within the vortex, expanding and cooling down. This cooling causes gases to condense to ices, creating a thick cloud cover high over the storm. Yet thermal infrared imaging reveals that the Great Red Spot has a warm heart. This warm area coincides with the deepest red cloud colors shown in the new images, and possibly a stagnation of the winds. Is this the core of the vortex, telling us what the storm looks like at depth? If so, what are the temperatures like well below the clouds? Again, Juno's microwave observations may well reveal the answer. Source: it's the initial force that will start the combustion process. It could be a spark, an electrical discharge, or a match like the one you have in your hand. And the last ingredient is oxygen. Yes, the same oxygen that we breathe. It's just as important to fire as the fuel itself. For an experiment, try lighting a small candle. Now cover it with a glass. You see how the fire keeps burning for a few seconds and then goes out. The fuel is still there, but the fire has used up all the oxygen inside the glass, and the burning process is over. The same thing happens on Jupiter. There just can't be fire simply because there's no oxygen, and you didn't even have to fly there to find that out. From Earth, we can see hundreds of thousands of little meteorites falling on Jupiter. The asteroid belt next to it is to blame for this. When they hit its atmosphere, they start to burn, and that doesn't instantly blow up the entire planet. But don't be upset, there's still a way to ignite this gas giant planet. All you have to do is trigger a thermonuclear chain reaction on the planet. Then there'll be an explosion so powerful it'll be visible from Earth, and it will be like the birth of a new star. To do that, we need to detonate a nuclear reactor like the ones that give us electricity here on Earth. In fact, we'd have to send everything we have to Jupiter, but even that won't do the trick. Big asteroids, when they hit the planet, cause a much bigger explosion. In 2009, meteorite the size of 5 soccer fields hit Jupiter. It caused an explosion of 5 billion tons of TNT. This incident left a dark spot the size of the Pacific Ocean, and an even bigger explosion happened there in 1994. After that collision, there was a giant spot on Jupiter, almost the size of our planet, but strong winds and storms quickly began to sweep away the traces of the explosion after a few weeks. Jupiter looked like normal. The problem is that our attempts to blow up the gas giant took place on the planet's surface. We need to plant a charge the size of the moon deep below it. Thanks for watching.